Welcome back once again. In this video, I'll be walking you guys through how we can combine serverless functions, Cosmos DB, blob storage, and queue storage to create a seamless workflow for managing upload and processing of images. I'll first start by showing you guys a quick overview of the function that handles the uploading of images and enqueuing of tasks to the queue storage. I'll then walk you guys through setting up the services and configuring role-based access control before then diving deeper into the code and how it ties everything together from uploading the files to enqueuing the tasks for further processing. By the end of this video, you understand how all these components work and see it in action both locally and in production. Let's get started. So this is a very quick overview of the HTTP function triggered by HTTP request. This could be an endpoint, but I decided to use a function to keep things simple. So first and foremost, you've got the function which gets triggered by a request and then passes the request body, which then proceeds to the first line of action. The first line of action is creating product action. So the way things are structured here might already be the way I did it later on, but you can decide to encapsulate everything in one action. So yeah, we've got the create product action. The create product action validates the product data and then stores the product using the Cosmos DB service. Then we have the upload image action, which validates the image format and then makes use of the blob service to store the product image or images in the blob storage. And then we'll have the update product action, which validates the product data and stores the product in the Cosmos DB service. And we've got the enqueue task action, which makes use of the queue service to enqueue tasks for image processing in the storage queue. So yeah, next up is creating the Azure services. So in order not to waste much time, I'll just show you guys a brief a summary of the services you need to create, but I'll be linking the readme file in the description for you to check out the detailed code you need to run in order to set up these services properly. So you have to first set up a resource group using Azure group create. Then you create a storage account. The storage account is for the blob storage and the queue storage. You then proceed to creating the queue using AZ storage queue create, and then you can create the function app. You don't have to create this immediately, but you can create it if you want to. You create the function app and then set up a managed identity for the function app and then assign it 2 roles, because you're going to be needing 2 roles to be able to access the blob storage and the queue storage. You're going to need, storage blob data contributor and storage queue data contributor. You might as well need those roles for your root user in your directory so that you can test locally. And then you need to update app settings for your function app, because you'll be setting up the settings in your local settings.json file for your function app in your local environment. So yeah, after this now, once all these are set up, next step is then proceeding to showing you guys how the code works. So yeah, I've got a simple function app here. So in the root directory, I've got the function project and the function test project. So inside the Funkify, I guess you all know how to set up a function project already using the function call tools. So all you have to do is just run the function in it and create a new function project. You can check it out using in your browser by going to Azure function call tools. Check out how to create a new project and set it up straight away. So this shouldn't take much time. So yeah, just go up here, then install the Azure function call tools and create your local project. I've created a .NET isolated project so I can set up various configurations for my whole functions. So in here, I've got my program.cs file. So in my program.cs file, I've got the services which I'm making use of. I've got the Azure services and I've got my actions. So in my Azure services, which I'm getting to you first, before I get to that, I'll just go one function, which is the product processing function, which is here. I'll get to this later on. So in the Azure services extension, which is listed in this extension directory, I've got the services which I'm making use of in this project. So first, I've got the storage account name, the queue name, and the Cosmos DB connection string. So yeah, I forgot to mention, for the Cosmos DB, because it's a trial version, you can't easily set up a Cosmos. Unless you're going to be paying for it, you can't set up a Cosmos DB free trial on your normal account. So you have to head over to Cosmos DB trial and then try Azure Cosmos DB for free. Then head over to display. to then set everything up. I've set this up already for myself, and because the Azure Cosmos DB service is in a different directory, I used a Cosmos DB connection string because I can't use the same identity to access that because it's two different directories. So I use the connection string instead. But for the storage, for the queue storage, which is the storage account, I made use of a managed identity because that is in my normal directory. So yeah, heading back to my code, I've got the storage account name, the queue name, and the Cosmos DB connection string. So these are all listed in the local.settings.json file, which is this. Then I've got, so you can just set up all this stuff here. So you have storage account name, the queue name, and the Cosmos DB connection string. Then heading back to the Azure Services extension of CS. In here, I set up my Cosmos client, which needs the Cosmos DB connection string, my blob service client, which needs the storage account. So you just make a URL. It's basically your storage account dot whichever service you're trying to make use of, which is .blob.core or windows.net for the blob service client, and .q.core or windows.net. But for the queue service, you need to create a queue to connect to, which I did create also. So I forgot to mention that in here as well. So when you create, I did that. So you create the storage account and then create a queue, which you will then access here to keep everything encapsulated in one. Then add all these as singletons. So you've got the Cosmos client, the blob service client, and the queue client. So in there, after that, I've got my services. So these services, I use these services to access these clients easily in order to keep things like separated and testable. So I've got the iQ service, the iBlob service, and the iCosmos DB service. In my queue service, I've got just one method, if I'm correct. So heading back to my contracts, I've got just one method for adding the message to the queue storage, and then for my blob service, I've got two of them, which one for getting the container and another one for uploading the blob. And then I've got the iCosmos DB service, one for getting the container, getting the item, creating an item, and updating an item. The reason why I did this way is to make sure for consistency and for flexibility in case maybe anything changes anything changes in the future, so it won't lead to breaking changes and everything. I mean, the whole test and all keeps running as expected. So yeah, I've also got tests in here as well for those services. So I've got the test for the queue service. I used mock to mock the queue client and just test my own implementation of maybe ensuring the messages and all are available and all know and stuff like that. Then we've got the Cosmos DB service test as well. All these things will be listed. All these things will be in the repository, which I'll link in the description. I've got the blob service test as well, working the same blob service client. Then after that, you've got the actions. So these actions then make use of these services which I have here. The actions which I have here make use of all these services, which are the blob service, the Cosmos DB service, and the queue service. The first action I've got is the create product, which I mentioned here initially. So the create product action, which has one method, invoke. It gets the Cosmos DB service from the dependency container, initializes the Cosmos DB service, gets the database name and container name. You don't have to hard code this. You set this up also in your lookout.settings.json file, but just to keep this simple, I set them up here. So the database name is Funkify and the container name is products. I've created this database in my Cosmos DB trial account. So after you've created the trial account, you'll be directed to this page where you can then proceed to your data explorer. Your data explorer then creates a new database and a container. My container here is product. And I've got a couple of items which I already tested with. So yeah, that's all for that. Then you have the invoke function for the create product action. The invoke function, which I already mentioned, it first validates the product data. So it validates the product data. This is not necessary. So the validate product method basically just checks if the product is null and ensures that the properties are in order before then making use of the Cosmos DB service to create an item. So heading into the Cosmos DB create item method, what we have here, so I should head into the Cosmos DB service. So what the create item does is to validate the item as well, doing the similar stuff, and then get the container which you've specified, and then create an item and return that item. As simple as that. After that, we've got the upload image action. The upload image action basically validates the input, so it ensures the container name and the file name are not empty, and ensures that you've sent in an image file. If it's not, it throws an argument exception. After it does that, it then uses the blob service to upload the blob to the blob storage. So I'll head over to my blob service. So this is the blob service. The blob service basically just gets the container client, uses the container client to get a blob client which is going to use to upload that blob to the blob storage, and then returns the URI as a string, which should then be used by the product processing function to then update the product unprocessed image URL. Then after the upload image, you have the adding images of the update product, or update product action is similar to that of the create product action. So it basically still does the same thing. It validates the product and updates an item. Then we have the enqueue tags. The enqueue tags uses the queue service, ensures that the message is not null, and then uses the queue service to add a message to the queue storage. So in the add message in the queue service CS, what we'll just do here basically is to use the queue client to send a message to the queue storage. And the last but not the least is the final, which is the entry point of the application, which is the product processing function.cs file. In the product processing function.cs file, we have our 4 properties here, or four members we should be making use of to process data coming in from the request. So we've got the create product action, the upload image action, the update product action, and the enqueue tags action, which are all gotten through the dependency container, which I defined here as singletons, because don't want to be managing state. So here we've got the function definition here, and the run method is triggered by HTTP request, HTTP post request. Sorry about that. And this is the walkthrough. So we first check. So I first check if it has a form content type, meaning if an image is included in the request, it processes it separately. Else, if it's just a JSON request, it creates a product without an image. So yeah, if it has an image in the request, read the form, and then get the name, the price, and the quantity. We check if the name is null, or we'll just do some validation here in the processing function, and then check if we have files that have been uploaded. So in here, we're checking if the files, if you have at least one file in the form.files array, basically. If I have a file, we'll check if the file is a valid image. So this check now could be done in the upload image action actually, but I did it here. So here we're checking if the uploaded image is a valid image, so using the extensions. And then if it's a valid image, we then proceed to using the file stream to upload the image. So basically we use the upload image action, which accepts the container, which is 1, the file name, which is gotten from the file which has been uploaded, and then the stream, which is gotten using the file stream, to then upload the image using the blob service to the blob storage. I can go back to show you guys the implementation. So basically this upload image action just takes the container which you want to upload to, the file name, and then the file stream, then makes use of the blob service, which basically uploads that blob to the blob storage. After that, we get the blob URI from the invoke method, and then update the product data using the blob URL. Then afterwards, once we've done all this, that after we set up the product object, we can then proceed to creating the products using the create product action. So the first product has been created. We then have the block of code to then enqueue the product, or rather to enqueue the tags for processing. So basically we check if the created product wasn't null, and if there's an unprocessed image URL, because what we're trying to do is to enqueue a task which is then handled by another function for processing the image. So here we're checking if the created product is not null, and if the unprocessed image URL is not null, because if the unprocessed image URL is null, means that the upload image action didn't upload the image. So after that, once we've done this, we then create a task using JSON convert, setting the product ID to the product ID that we want to process the image for, and then the product image URL, because these are the two information the other function will be making use of to process the image. So it needs the product ID and the image URL, which is to use to access the blob container, get the blob, process it, resize it, optimize it, and then use the product ID to fetch the product info from the Cosmos DB database and update the processed image URL for that. Once that is done, we use the enqueue action to invoke the send message async queue client method to then add the task for processing. We'll just go loggers around, just go loggers everywhere here, just for like to ensure that things work properly, and then we return an OK object result. And I've got various error handlers. So yeah, I start from the specific ones: the argument null exception, the argument exception, and the rest. So the reason why I did this way is the reason why I'm handling the exceptions here, so I can easily return readable messages to the client instead of like handling it maybe somewhere else in the actions and maybe throwing it, or rather throw it in the actions and then bubble it up to the controller, something like that, or rather to the function, which then handles it and returns it directly to the client. So yeah, I'll just go ahead and run this now. I'll run func start. See, the function is running locally now. I'll just go ahead and bring out my postman. See, I've got my postman over here. I've been testing this already, so all you just have to do is specify the name. So basically the function, a product needs I forgot to mention that as well. So a product model needs a name, price, quantity, and then you can upload an image which will then be processed. So yeah, if I decide to just send in a normal raw JSON file or raw JSON body, I get a response without the processed image URL because I didn't upload an image for it. Price, and then quantity. So yeah, we created a new product, but because we didn't upload an image, we don't have the unprocessed image URL. If we go over to Cosmos DB database now and refresh, you can see the newly created product. If I then decide to use a form data to send the request, I'll call this new product form data. I'll set the price to 1080 and the quantity to 120 with an image already uploaded, and send this request. We get a response with the unprocessed image URL linked to the Funkify storage account blob container. So you can see this. So this Funkify storage container.blob.code or windows.net/unprocessed images/multitenant.png, meaning that the image has been successfully uploaded. So I'll go back to my Cosmos DB database and refresh. So in here you can find this. So you can see that the image has been uploaded. And if I also proceed to if I go over to my containers, I can find the unprocessed, I can find the multi-tenant image which was uploaded by 3:40 p.m. which is here. You might try, so when you try viewing this image in your browser, you might get errors about public access denied. To solve that, all you have to do is just head over to, so yeah, that works for me. But if you get the error message showing public access denied, you just have to head over to your configuration under settings and enable blob anonymous access. This is not recommended, but just for testing purposes, you can enable this. Ideally, you could make use of SAS tokens to allow limited access to the resources or limited access to your containers and blob. So once you've enabled this, just head back to your containers then unprocessed images, and allow that specific container and change access level. So my access level is just for the blobs alone, so you can't look into the container. You can just view the blob specifically by providing the URL. So yeah, that sums it all up for making use of a serverless function for processing the product information, uploading the image, and then encoding the tags locally. For production, you just have to set up a function app. So you set up a function app, ensure you have the roles set up as well, and then set up the various settings which are needed to make use of the various services in Azure. So once you've got that up and running, it's basically the same thing. Just use the same URL for your function app. I think I've got mine here already. So let me just go over to my funky file. I'll copy this URL and I'll use this here. And I'll proceed to send in a new request. So yeah, this works fine. So yeah, just the same stuff I did locally is the same stuff that is in production. I made use of GitHub workflow file for automating the deployment. Everything is linked in the description, so you can check it out. So yeah, that sums it all up about using serverless functions to manage uploading and processing of images using various services in Azure. In a later video, I'll be walking you guys through how you could process this image using another function and store it back in the Cosmos DB database.
Preview.